And this is something you have to know how to do this well to do the next couple of sections that we're going to do, actually. Okay, so implicit differentiation. So first, what we're going to look at, the first thing you got to understand about this is sometimes you have equations that are very difficult to solve for y, if not impossible. Okay, and we're going to talk about that a little bit. So first of all, just a little bit of terminology. If you have a function that's solved for y, that's called the explicit form. Okay, you got it, and you're going to differentiate that. Like if you did the derivative of this, of course you would get y prime is equal to 6x, right? Problem would be done. Okay, this is another example. This one is explicit form. It just means that you're solved for y. And there's no problem doing the derivative when you're solved for y. This derivative, how would you do the derivative of x to the negative 1? Just power rule, right? Negative 1, x to the negative 2. Okay, like that. Okay, that's explicit, means you're solved for y. Okay, now this right here is what we call an implicit form. And an implicit form means that it's not solved for y. Now this one would actually be very easy to solve for y. How would you solve that for y? Just meaning get y by itself. Y by x, okay, it'd be a piece of cake, okay? But that's still in an implicit form. Now what you get into in mathematics a lot of times is you might have something like this, and for whatever reason there might need to be doing a derivative. You would struggle big time trying to solve that for y. Okay, I mean getting just y equals something would be tough. I mean, you could move the x and the x to the 7th, but you're not going to be able to transition that in any way, so it just becomes a y. So that one you could not solve for y. And if you do that, that's when we use implicit differentiation, okay? So next thing I want to look at is just kind of, let's look at some equations and let's think about whether or not we can solve them for y, okay? The nice thing is if you can't solve them for y, then you can still work with the derivative and find rates of change. Okay, let's look at this first one. Could you solve that for y? Okay, let's try it. Well, first thing you'd probably do is move the x to the other side, right? Okay, and if you did that, you would have y squared equals 25 minus x squared, right? Okay, then what? We're still not done. You can do the square root, okay? So you could do a square root of both sides. And when you do this, you've got to know this from your background, you have to introduce the plus or minus. Okay, maybe you've done that before. Does that look like something you've done? Like if you have y squared equals 4, there's two answers to this equation. There's 2 and there's negative 2, right? So if you do a square root of both sides, you got to remember that part. But anyway, we solved it for y. So it started in the explicit form, now it's in the implicit form, okay, like that. How about the next one? Could you solve that for y?
No.
If you can, I'm just curious if you know how. Look at the left side. Is there anything mathematically that you could do with that left side? You can take a y out, right? You can factor, okay? So yes, you could solve this for y. You could take the y out, and if you did, you would have x minus 1 equals 7. That's factoring, okay? Right? Now what do? Divide by x minus 1. Okay, so yeah, you could solve this one for y. So if you were going to do a derivative of this, you could solve for y, and then that looks like that would probably be you could either do a quotient rule or you could do a general power rule. We did that last time. Okay, so you can do that. Now let's look at this one. That one looks pretty crazy, doesn't it? Okay, I mean that one, I don't know. How are you going to get y by itself? I mean, you got an e, you got an ln of y. That one you would struggle big time with. You could play with it and you'd just run in circles. So this one is one that you can't, I guess I should say, you can't solve for y. Okay, so the point I'm trying to make is sometimes you'll have situations where you can't solve for y, and if you're still working with the calculus and working with rates of change, you can still do that okay, all right? So does that make sense what I'm talking about? Okay, just solve for y, not solve for y. Explicit form, implicit form. Okay, now, since we've learned the chain rule, you can't learn this until you learn the chain rule. So the idea I want to kind of get to what I mean with variables agreeing and variables disagreeing, and just kind of talk about that. So if you're doing the derivative of x to the third, the thing is these variables match. Okay, when you have that d dx, it's saying take the derivative with respect to the variable x. So those variables match. You already know how to do that. Okay, you got that down. Okay, but if you have a situation like the next one, you're doing a derivative of something with y in it, and you're doing it in terms of x. So this is what you have to understand in order to do implicit differentiation. So actually the way you do this is you do this like this. Okay, you already know how to do the derivative of y to the third. That's 3y to the second, right? But there's really a chain rule going on there. That's not the same variable, so you have to multiply by the derivative of that thing, which is dy over dx. So you got to write it that way. So if those variables do not agree, you have to add that in. Okay? And you'll kind of see a little bit more why we're doing this once I get through the full stage of implicit differentiation. So if they don't match, then add in that dy over dx. Okay, just for now, let's kind of get comfortable with doing that before we talk a little bit more about why that is. Okay, let's look at this one. Okay, do these variables match in this derivative? Yes. Yes. Okay, so yeah, the variables match. So we're not going to use the chain rule, so we just use like a power rule. Like this, and of course you guys already know the answer. That's 10x to the 9th. Okay, everybody's got that. Okay, look at the next one. Do the variables match? No. Okay, so the variables don't match. Okay, so when they don't match, what you really do is you really use the chain rule. And it's real easy to do this. You just got to remember that extra piece when you do that. So this derivative goes like this. The derivative of y to the 10th is 10y to the 9th, but then you have to add in this dy over dx. You're really multiplying by the derivative of kind of what's inside. It's a different variable, so you have to do that. If the variables don't match, you must add in that extra piece. Okay, everybody got that? Okay. All right, let's work with this a little bit more before we get into the implicit. Okay, here's how you're going to do this. Now, you're going to have a matching variable here. So first of all, let's write this out like this. We know we can do it when we do a derivative of a sum, we do the sum of the derivatives. Okay, so let's start it by kind of writing it that way and kind of getting that put together. Now, you can do this in your head, but I want to kind of carefully write that step out like that. Okay? All right, let's look at this first piece. Do the variables match? Yes. Yes. So what's the answer to that part? 2. Okay, that's good. We don't have to worry about anything. That's 2. That's done. Okay, how about the next part? Do the variables match? No. No. Okay, so what you do is it goes like this. First of all, the derivative of 4y to the second is what? 8y. 8y, then what? dy over dx. Okay, they don't match. That's where that goes. Okay? Just get trained to do that for now, okay? Like I say, it'll start making a little better sense why we do that in a minute, I think. But just get to where you can do that, okay? All right, now the next one. All right, now you got to look at this like this. This is 2 functions. The first function is x to the third. The second function is y. You got to look at that as 2 different functions multiplied by each other, not just one big function. So if you have 2 functions multiplied, how do you do the derivative? You do the product rule, right? So I'm going to just write for reference the product rule. You got the first times derivative of second plus second times derivative of first. Okay, so you need to put it in that formula when you do that. Okay, all right. So what you do is the first is x to the third times the derivative, and use that same notation. We're doing the derivative with respect to x of y plus, and do it backwards, second times derivative of first like that. Okay, does everybody understand why I'm doing the product rule? A lot of times students will just do like 3x to the second times 1. Okay, can't do that. If you have a product, you have to use the product rule. Okay, so that means we need to focus on this thing and we need to focus on that thing. If we do those right, we're done. Okay, so I'm going to bring down this x to the third. Now see, here the variables don't match, okay? And see, what you're really doing is the derivative of y is 1, right? just like the derivative of x would be 1. But since the variables don't match, you'd write dy over dx. And you can do that in your head. You could just write dy over dx, okay? All right, now how about the next one? Do the variables match? Yes, so what's the answer? 3x squared. So there you go. Okay, so see, you have that one situation right here where the variables don't match. So that means the derivative would be written like this. It would be written as x to the third dy over dx. I'll put a times there. And then you could write this in either order. I'll just write this as 3x squared y. So that would be the derivative of that expression. Okay, like that. Okay? Does that make any sense? Okay? Pay attention to whether those variables match or not. That's what I want to get you comfortable with. Okay? Any questions?
So you write dy over dx as part of the answer?
Yes. Yeah, and you'll kind of, once we do implicit differentiation, I think you'll see a little bit better why we're doing that. I'm just trying to get you comfortable with writing that correctly right now. Okay? That is a part of the answer. Okay, how about this one? Any idea about how you do this one? Quotient rule, good. Okay, you got a quotient, so let me write that down so we can kind of refer to that. That's quotient rule is bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, so we want to go ahead and start putting this in your quotient rule carefully, and I would just write everything out before I start doing this in my head. So the bottom is e to the x, then you're going to multiply by the derivative with respect to x of the top. Okay, then minus, then do the top, 3y, and then the derivative of the bottom. And then we have the bottom, whatever the bottom is, make sure the whole thing is squared like that. So that's your quotient rule, like that. Okay, so what we actually have to do on this is we have to focus on if we can get this right and get this right, and then just see if there's any algebra we can do. Okay? All right, let me see if you guys can do this now. What is this? 3 times dy over dx. The variables do not match, right? They do not match, so that's what you have to pay attention to. So you're going to have e to the x. That's going to be 3, but don't forget the variables don't match, so you must have that. Okay? All right, what's this? E to the x. The variables do match, right? So it's just e to the x. Okay? So that means we'd have minus 3y times e to the x like that. Okay, let me see if you got your algebra. Do you guys know what that is? E to the 2x, right? You multiply exponents. See, there's basic exponent rules you have to be on top of. If you had x to the third to the second, that's x to the sixth. This is the same idea. It's 2 exponents. So you're going to write that as e to the 2x. Okay, like that. All right, now we do have some algebra that can happen on this one. All right. So anyway, that is the derivative. Now let's look real carefully and see if we see anything in the numerator like this. And so you got to look at these things the right way. You kind of get bigger, more complicated expressions in calculus. Those are the two terms right there. What's in common in those two terms? A 3 and an e to the x, right? Take it out. So you want to take that factor out when you do that. So take 3e to the x out, like this. Then you can have either a parenthesis or a bracket, doesn't make any difference. So that's already been taken out, so that means that's a dy over dx. Okay, we've taken out the 3e to the x there, so that means we have a minus y, and it's all over e to the 2x like that. Okay, now there is one other little thing you could do on this. Okay, do you see anything else you could do? You do have some cancellation. See, these things right here are a factor that's similar. It's no different than having this. If you had x to the first over x to the second, what is that? That's just x over x times x, so it's 1 over x, right? Or you can say, subtract the exponents, 1 minus 2 is negative 1. You can do that either way. So these things do cancel out. So you would have 3 times dy over dx minus y, and one of those cancels out, leaving you e to the x. Okay, if that is something that you struggle with understanding, understand that what that means is that's e to the x over e to the x times e to the x. That's what e to the 2x is. One of them cancels out. Or the other way to look at it is just 1x. If you're looking at this piece right here, it's x minus 2x. And if you subtract the exponent, you get e to the negative x, right? Okay, so tell me, this is the stuff that students have the hardest time with in calculus, is all this stuff. Okay, any questions about all that algebra? Okay, see some weird looks out there. My job's kind of help you guys with that, because that's the part you're going to get into. All right, okay, now let's get into the implicit stuff here. Okay, so on this next page, I've kind of given you the guidelines that you're going to go through when you do implicit differentiation. Now, what we're going to do with this, if I say do a derivative by implicit differentiation, then you don't have to worry about solving for y. So sometimes I might have you solve for y and do a derivative. This problem right here is just as easy to do implicitly, okay? So here's how you do this. This is what the way you need to start is like this. You need to go ahead, we're going to find dy over dx. So you need to start by doing the derivative of both sides of the equation. And I'd write every little step out when you're learning this. So we're going to do the derivative of this whole entire left side, and then we're going to do the derivative of this entire right side like that. Left side, right side, okay, like that. So you're going to do derivative of both sides. Okay, if you do a derivative of a sum, you do the sum of the derivatives. Now you can do this in your head if you want to, but since I'm teaching this, I'm going to go ahead and have you write it like this. Okay, now what's the derivative of 8?
0.
0, that's a constant, so we can go ahead and do that. Okay, so we got that. All right, now we're going to look at the little pieces the way I was trying to kind of get you going on this, because you have to do this right to do this implicitly. Okay, all right, tell me what the derivative with respect to x of y to the second is. 2y dy over dx. Good, okay. Got to be careful there. 2y times dy over dx. Technically, it's a chain rule. Okay, what's the derivative of 3x? 3. Why do you not do dy over dx? They match. Good. Okay, so I can tell you guys are starting to get this then. Okay. All right, so we got that. All right. Now, what we're trying to find is dy over dx. See, this is like a variable. You're just going to solve this equation for dy over dx, then you have the derivative of that function. Okay, so really all you're going to do is you can move the 3 to the other side because you're solving an equation. So you'll have 2y times dy over dx is equal to -3. Okay, like that. Okay, I still got to get dy over dx by itself, so tell me what I do. Divide by 2y. It's just an algebraic equation. So good, you want to divide both sides by 2y, and then you're done. Okay, so what you're going to get from here is dy over dx is equal to -3 over 2y. That's it. Now what's different to this from students is notice our answer has a y in it. Okay, it's okay. That's the derivative of that expression. Okay, so that's how you do implicit differentiation, is you do a derivative of both sides with respect to x, and then ultimately, you have to get that by itself. You have to solve for that because that's what we're trying to find anyway. Okay, did you guys follow that okay? Okay, that's not too bad of an example. They get more complicated, of course. That's pretty straightforward, not too bad. Any questions? Okay, now here's the thing that's kind of nice about doing implicit differentiation is if you want to find the slope of a tangent line, if I give you a point, then it's easy to find that, because a derivative is giving you a slope of a tangent line. Okay, so all you got to do is plug it in. So if you want to find the exact slope of this tangent line, well, this only has a y in it. The derivative only has a y. Well, what is y? Y is square root of 5. So you plug it in and then you're done. Okay, so you would just have -3 over 2 times the square root of 5. That's your slope of your tangent line right there. Okay, that's it. Okay, that's the way that would work out. So you also want to know how to do that when that shows up. Okay, does that make sense? Okay, if I give you a point to find the slope of a tangent line, plug it into the derivative after you've done it implicitly. Okay? Okay, now let's do this now. I want to kind of show you an alternative way to do this problem. Then we're going to look at graphing this on the calculator and try to make sense of this, because you want to make sense of what we're doing. So let's write down y squared plus 3x equals 8. Now I'm going to show you a different way to do the problem. Okay, and this way is, if you're doing it this way, it's better to do it implicitly. So what we're going to do on this is we're going to solve this for y, since we can do that. So we're going to just do that. You would have y to the second is equal to 8 minus 3x, like that. Okay, and then what would you do? Square root. Okay, so you would have y equals, and here's where you got to be careful, you would have plus or minus 8 minus 3x. Okay, now you guys know how to do the derivative of that. Okay, I've taught you how to do derivatives of square roots. What do you typically do? Change it to a half power. Now this is going to be a chain rule. So let's write this as y equals plus or minus 8 minus 3x to the 1/2 power. Okay, and then we're going to see if we can get the slope of the tangent line at this curve, and we'll look at the graphing calculator. Okay, when we have that plus or minus, we can just leave that in there. So if we're doing dy over dx, okay, it's chain rule. Okay, so we're going to bring down the 1/2. So you'll have plus or minus 1/2, 8 minus 3x, subtract 1 from the exponent. You can do that in your head. I'm going to write down what I'm doing. What else do you got to do? Derivative of what's inside. Okay, this is a chain rule. You have a function inside of another function. So when you do the derivative of what's inside, what is that? Negative 3x. Okay, like that. Okay, so what you'd have then is you would have plus or minus 1/2.
Would it be negative 3?
What's that?
Would it be negative 3? No.
Oh, just 3. Okay, yeah, just 3. Is that what you're saying? Okay. Yeah, the derivative of 3x, negative 3x is negative 3, sorry. So you can multiply these fractions. So 1/2 times 3 over 1 is really 3 over 2. You still have the plus or minus. It doesn't matter. I mean, you still have one of each. So you'd have that, and then we'd have 8 minus 3x to the negative 1/2 power. Okay, now that derivative looks totally different than the one we got implicitly. Implicitly, we got this. And then this way, if you solve for y, you got this.
Would that be negative 3/2, or?
It's because you have, it would, but you still have a plus or minus anyway. That's the reason I'm doing that. That isn't really going to affect anything, because if you have the plus 1, it becomes negative 3. If you have the minus 1, it still becomes positive 3. So that's your derivative. Okay. Okay. So let's get your calculator out, and let me go over a couple of things on this. And let's just kind of look at how this goes. You really, on these problems, you really can't interpret these very good unless you can solve your equation for y. So what I'll have you put in, you want to get everything cleared off. And let's see, let's go back to where we solved this for y. This is where we solved it for y. So you actually have to put two things in. You have to put the plus part in and the minus part in. So in y1, you want to go ahead and put in square root 8 minus 3x, like that. Just have the plus. And then you got to go down to y2 and put the minus in. So use your negative key and do the same thing. Just do square root of 8 minus 3x, like that. Okay? So that's how you would graph this. And this thing's going to, it isn't a function. It's going to fail the vertical line test. So now go ahead and just do like zoom 6. Do like a standard window if you want to. And let's see what happens. Okay, see that's the upper part of the curve. That's the lower part of the curve. So what it is it's a parabola. But it's a parabola going sideways. It's not a function. So if you're looking at the slope of the tangent line at this point, okay, let me show you something on this. So we were looking at the slope of the tangent line at this particular point 1, 5. So just go ahead and type trace 1 on that. And if you were looking at the slope of that tangent line at that point, can't you see that that's at least sloping downward? Okay, so it is a negative slope for that reason. Okay, but there's another point. There's also the point on this, there's also the point 1 negative square root of 5. And if you did the slope of that tangent line, it'd be positive. Okay, that's why you're getting that plus or minus in that particular function then like that. Okay, so you can still do calculus and derivatives if you have something that's not a function. Can't solve it for y, that's why it's not doing that. Okay, does that make any sense? Visually? Okay. Got to try to make sense of this stuff as you're learning it. There's always the mechanical part certainly, but then there's the understanding, which is big. Okay, I'm going to do one more example, and I'll let you try to do one yourself and see how you do. It's the only way to see how you're grasping this. Okay, so this one I'm going to do, I'm just going to do implicit differentiation. This one would be very difficult to solve for y. Although there is a y squared, there's also an xy in there, okay? So you want to start this like this. You want to go ahead and write down that you're doing d dx of the left side. Go like that, and then you're going to do the derivative of the right side like that. So we want to go ahead and do that and do it very carefully. Okay, now what we can do on this is we're doing a derivative of sums, so we can do the sum of the derivatives, and let's just write it out. We're doing the derivative of y squared plus the derivative of xy, and then plus the derivative of 3x, and then what's the derivative of 9? Okay, so that'll happen some, but not always, okay? So now what we need to do is we need to figure out each of these individual derivatives and carefully do all these things correctly. Okay? All right, tell me what the derivative of y squared is. There you go. The variables don't match. So that is 2y, like you're used to, but times dy over dx. So you got to have dy over dx in the equation because that's what you're trying to find. Okay? How do you do the derivative of xy? Product rule. It's product rule. There's two things there. There's an x and a y. Yes.
So it says to find dy over dx, so like you always start with d over dx?
Yes. Yeah, you're doing the derivative with respect to x. dy over dx is what that is saying is that's the derivative of whatever you're doing a derivative with respect to x. If I say d over dx, that just means take the derivative. dy over dx is the result, say. That's the difference in the notation. So we're going to do a product rule here. Okay, so I'm going to put a bracket, or let's just do it like this. Okay, so I'm going to write down the first, and then I'm going to do the derivative of the second, which is y, then do it backwards, plus the second, y, times the derivative of the first, like that. Okay, so we got that. That's your product rule right there. Okay, I'm just kind of highlighting that right there. Okay, what's the derivative of 3x? 3. The variables match, so you don't have to worry about it. Okay?
Wouldn't that be 1, though? Plus x, it wouldn't be 1?
Which part are you talking about?
Right there.
In the middle?
Yeah.
Now I'm doing a product rule, so I haven't really done anything yet but doing a product rule. So I'm going to do the first x, that's your first function, then I do the derivative of the second, then backwards, plus the second, derivative of first. Now we're not done with the derivative yet because we got to do that derivative, and that one's 1. If that's what you're thinking about, yeah, I'm just not there yet. Okay, is that what you're asking?
No, I didn't even know. I'm confused. I didn't know you were setting up the product.
Yeah, it's a product rule. See, what you have is two functions. You have two different variables, so you have to use a product rule because there's two things being multiplied. Okay, so that means what we need to do is we need to do this derivative and then that derivative, and then we solve for dy over dx. Okay, bring everything down. So this is 2y times dy over dx. Okay, x comes down. Now see this right here, technically what you're doing, and let me write this at the side of the paper here because you just do this in your head. The derivative of y is 1, right? But the variables don't match, so it's dy over dx, right? So you just write dy over dx. Okay, but that's the thought process. It's 1 times dy over dx. Okay, now the next thing, okay, what's the derivative of x? 1. Variables match, so you have that. Okay, so we've done the derivative. We're not done because we got to solve for dy over dx. Okay, you guys see what I'm doing all right? Okay, all right, so let's write one more step, then we'll kind of talk about how we finish it. So I'm going to write, just bring everything down. There's a few things I can do here. I mean, you could bypass this step too if you wanted to, because all I'm going to do is y times 1 is y plus 3 equals 0 like that. Okay? All right. Now, what do I need to do to finish this thing up? I have to solve the equation for dy over dx. Okay? So, here's the way you think of this. Anything that has a dy over dx in it needs to be together on one side of the equation. Anything that does not needs to go to the other side. So the y and the 3 need to go the other side. So what you'll have is you'll have 2y times dy over dx plus x times dy over dx equals, and then this is going to be negative y minus 3, because you're just subtracting y and subtracting 3. Okay? Now, look at the left side. Remember, you need to get just one of those dy over dx's. Any idea what I could do? And factor. Okay, factoring's a big deal here. See, this is a factoring problem. You have a common factor in between those two things, so you take the dy over dx out. So if you do that, you're going to have dy over dx times 2y plus x equals negative y minus 3. Okay, one more step and I'm done. What do? You need to divide by what you're trying to get rid of, right? Okay, you're trying to get dy over dx by itself. It's multiplied by something. So what you want to do now is just divide both sides by 2y plus x over 2y plus x. I like that. So that would give dy over dx is equal to negative y minus 3 over 2y plus x.
Cancel out the y's.
Nope, we're done, because we're trying to find what dy over dx is.
Could you cancel out the y's on the right side?
No. Okay, I'm glad you pointed that out too. If you're thinking about canceling that, what keeps that from happening is that. You can only cancel if you had like negative y times 3 and 2 times y times x, yes you can. Because if everything's multiplication, yes. But if you got plus sign separating stuff, it doesn't work. So you got to be careful about stuff like that. So that's it. Okay, you guys got any questions about what I did? Okay. Now what we typically do for now is we're going to find the slope of the tangent line at a particular point. So basically this just means x is 2, y is 1. So you want to take the expression that we got, which is what I'm highlighting, and you just plug x and y in and calculate the arithmetic. So what we'll have on this is negative y is 1, minus 3 over 2 times y, which is 1, and then plus 2. So just y is 1, x is 2, plug it in. Okay, calculate it out and see what we get. So this is negative 4 in the numerator over 4 in the denominator. Slope of the tangent line is negative 1. Okay, so you can still work with that rate of change, even though this kind of thing, you would have to have a computer to graph this. These graphing calculators don't graph this kind of stuff typically. You have to have some more advanced technology, but it would end up being some curve. I don't know even what the curve would look like, and that would be the slope of the tangent line. Okay? All right, you guys try the next problem. And I'm going to just give you a point to plug in at the end, even though it's not going to be a correct point. So also find slope of tangent line, let's just say at negative 1, 2, okay? Even and the reason I'm just making up a point is because it's real hard for me to just pick x and try to figure out what y is. So I'm just saying, let's pretend that the point negative 1, 2 is on that graph, okay? And I'll walk around and see how you're doing, because I need to kind of get an idea of how well we're catching on to this. So again, just start by taking the derivative of both sides. And that's what you got to. All right, so what you want to do is start this like this then. You're doing the derivative of the left side. I'm just going to kind of write it like this. I'm going to go ahead and do the derivative of x squared, do the derivative of x the third, and the derivative of e to the y. And you can start the problem like this if you want to, so that's because you're doing the derivative of each part anyway, because it's sums. Okay, so what's the derivative of x squared? 2x, derivative of x to the third, 3x squared. Here's the one possible slip up. What's the derivative of e to the y? Okay, you got to make sure you have your dy over dx. Okay, you want to make sure you did that. Okay, then how about the next one? 8y dy over dx. Okay, like that. So you got to have that. Okay. Now what I did, I just thought it was easier to move this. Okay, because then I only have to move one thing. Those of you who moved the dy over dx to the left, you probably moved the 8y, then the x stuff, right? Which is okay. So what I'm going to do is just leave this as 2x minus 3x squared equals, and then 8y dy over dx minus e to the y dy over dx like that. Okay, just move it. Okay, then what you can do is you can factor. So this is going to come down. You can take the x out, but you don't have to. And then this would be dy over dx times 8y minus e to the y. All right, then you would divide by that and you'd be done. And you can do that division step in your head if you want to. So you would have dy over dx is equal to 2x minus 3x squared over 8y minus e to the y. Okay, that's one way to do it. Okay, so the key thing is, if you didn't get this, you got to make sure you have that, and then you got to make sure that you're correctly getting the dy over dx by itself, because that's what you're solving for. Okay, is there anything that anybody doesn't understand? Okay, let's see, what's the point I gave you then? I gave you -1, 2. So regardless of which way you wrote that, you'll get the same answer. Your answer could also be backwards on this, I guess. So what I'm going to do is just do, where I see an x, I'm going to put in a -1. So you'd have 2 times -1 minus 3 times -1 to the second. And then the y is 2, so you'd have 8 times 2 minus e to the second. Okay, and then that would be -2 minus 3 times 1, and then 16 minus e to the second. So that looks like -5 over 16 minus e to the second. Okay, those of you who did it the other way, did anybody get 5 over e squared minus 16? That's also okay. Yeah, you would have got that. I think those of you over here who did it the other way would have got that. And e to the second, you just leave it alone. Okay, that's an irrational number, so you'd have that. Okay, how's that look? Okay, all right, so the next thing I want to do, I'm going to finish up with one more example that I'm going to do that's a little more complicated, but that's probably about the level you're going to do. If you can do that okay in class, you're not going to see anything much different than that. It's not going to be much more complicated, I don't think. So that's the idea. Okay, let's finish up this, and then we'll take a break. So we want to go ahead on this one and do the derivative of the left side, which is xy plus 1 to the third. And then we're going to do the derivative of each piece. Okay, you can save a step by just saying, okay, I'm doing the derivative of x minus the derivative with respect to x of y squared, and then plus the derivative of 8 like that. Okay, so we need to just focus on each of these derivatives and make sure we do them correctly. Okay, let's start with this one.
Product rule.
It's a part of it, okay, but that's not how you start. What do you see? What's the big thing? Always look at the big function. Something to the third, okay? You're right, product rule's in there, okay? Okay, now you caught on because I did the derivative of xy a minute ago. Okay, so how do you do this? You bring the 3 down, okay, then you have xy plus 1 to the second. Okay, then you got to do this. Then you got to do the derivative of what's inside. So we're going to do ddx of xy plus 1 like that. And we'll do that in a minute. Okay, so that's the chain rule. And yeah, the product rule is going to be a part of when we get to that inside part. Okay, that's the hardest part of this problem. Okay, now the right side should be pretty straightforward. What's the derivative of x? 1. Derivative of y squared? 2y times dy over dx, and of course derivative of 8 is 0, so you don't even have to put anything there. Okay, so we got that. So that means the next thing you need to focus on is doing this derivative. Okay, And everything else, just kind of bring it down. So we'll have 3 times xy plus 1 to the second. Now when we do the derivative of what I've got in yellow here, this is going to be a product rule. So the derivative of xy, you're going to put that in a product rule. So it would go like this. It would be the first times derivative of second plus second, y, times derivative of first, which is x. And then what's the derivative of 1 going to be? 0. I'm just going to put that in there to emphasize, and I'll pause there a minute so you can get that written down and make sure we have that down, because to me that's the hard part of the problem, is doing the derivative of that xy plus 1 to the third. So again, I have first derivative of second plus second derivative of first, then derivative of 1 is 0. Does that look okay? Okay. Now we just need to finish up with this, and then we need to think about how we're going to solve for dy over dx. Okay? All right, so let's bring everything down. It's getting kind of messy. They do sometimes. So we have that. Okay, now inside of this you would have x. This would be dy over dx. Okay? Nothing else you can do with that. If you do the derivative of y, it's 1 times dy over dx. Okay, and then the derivative of x is 1. Don't need to put the 0 there. Then we have that. So we've done all of our differentiation at this stage of the problem. Okay, it's a little messier because of that left side. Okay, now the focus becomes, we have 2 of these dy over dx's in the problem, so somehow we got to try to get all those things by itself. Okay, now watch this carefully because it can get a little tricky here. So what I'm going to do here is, I'm going to do a distributive property. Okay, what you have here, that's one big term. That can be multiplied by this, and then it can be multiplied by this. You're going to have to do that. That's the only way you're going to get that dy over dx contained the way you want to. So if you do that, you're going to have this. Do this first term. 3 times x is going to be 3x. Then you have xy plus 1 to the second times dy over dx. Okay, what I did is I did this times this. That's a distributive property. I just brought it down. Okay, 3 times x is 3x. That comes down. I've got that. Right? Distributive property. Think of this as one gigantic thing. A lot of times students don't see the terms the right way. That's a term. That's a term. That times that is just going to give you this. Then you're going to take this times y. So what you'll have next is you'll have the plus, and then you'll have 3 times xy plus 1 to the second. And I'm going to put the y in like that. And then we'll have 1 minus 2y times dy over dx like that. Okay? I can tell some of you aren't seeing that distributive property. It's just this times this. Right?
I just don't understand why you put the 3 and the x together right in the front.
I don't have to. It just did that because it looks better. Okay?
Gotcha.
All right. The thing about that is you can put things, a lot of times if you have parentheses, it's good to just put the simple stuff in front, like the 3 and the x and stuff like that. That's why I put the y with the 3. It's like that. Okay? Now, here's what we got to do to finish this up. Now, what I'm going to do is I'm going to draw a box around anything that has a dy over dx. That thing right there is a big piece, and that right there is a big piece as well. Those things need to be on one side of the equation. Everything else I didn't box in needs to go to the other side. So what I'm going to do is I'm going to bring this down. I'm going to leave this where it is. Just rewrite it. So that's 3x, xy plus 1 to the second, times dy over dx. This is going to move, so the minus 2y becomes plus 2y. Okay, and then we're going to move this. The 1 stays. It doesn't have a dy over dx. And then this moves because it also does not have a dy over dx. This is almost always how you finish these problems. Anything that has dy over dx together, anything that doesn't together on the other side. Okay, now what? Factor. It's almost always what you do. See, this is a common factor. Okay, now that's it. So that thing comes out. So you're going to take that common factor out. So you're going to have dy over dx I have a bracket, and see, this might help you if you just kind of block that off in your mind. Write what's left. Just bring it down. You'll have 3x, xy plus 1 to the second, plus 2y, equals 1 minus 3y, xy plus 1 to the second. Okay, what's the last step? Divide by this mess. See, that's something times something, so you divide by the whole thing. Now, you can do this step in your head, because once you divide by that term, you're going to have the answer. You'll have dy over dx equals 1 minus 3y, and then that will be, let's see, xy plus 1 to the second, all over 3x, xy plus 1 to the second, plus 2y. Now, there ain't going to be any simplifying on that one. We're done. Okay? So, see, they can get kind of complicated like that when you get some really messy expressions. But if you follow every little detail of it the right way and look at the algebra right, then you can do them okay. That was pretty messy. Okay, now you'll kind of see why in the next section, why we do implicit differentiation. I'll show you when we get back from break. Also, a business example where you pretty well have to do it this way. Okay, so let's go ahead and take a 10-minute break.